Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this video, we will be discussing about the distance metrics that we have in KNN. I would say कि this specific discussion of distance metrics is not only applicable for this KNN specific algorithm, but also in future you will observe that when we are talking about unsupervised machine learning algorithm, there also we have another algorithm called as k-means. The same discussion is equally valuable there as well. So please try to understand each and every point, each and every way of getting the distance value, that how the two distances, 2 points are specifically far from each other. Specifically, there are three ways which we will discuss in this video. One is Euclidean, another one is Manhattan, and at the very end I'll talk about that. Okay, when we're talking about Euclidean and Manhattan, that's a numeric data points discussion, but let's say you want to deal with the categorical data. In that case, there is another distance metric that we have, which we call as Hamming distance. So let's try to deep dive into all these discussions. Apart from this, you will observe at the very end I'm talking about k value, that what is the meaning of k, how we will be able to decide that for which particular data set what is the optimal value of k we would choose. And if let's say we are just calling the KNN and we're not defining the value of k, we will refer the documentation, we will see that what is the default value it will choose again and again. Okay, so without wasting any time, let's get started. So whenever we are talking about the distance metric in KNN, and be it further algorithms where we will talk about k-means as well, so the explanation will remain same, because we do have various different types of metrics with the help of which we will be able to examine that how much distance any 2 points would have. So I hope you all remember in the previous video we have discussed about that how KNN algorithm works, right? Basically, k stands for the number of data points, nearest data points that we have to look upon. In the classification task, we will try to work upon the probability, and in the regression task, we will try to find out the average of the nearest points that we have, right? That's what we have discussed. Now, usually that is the major reason you will observe it is recommended that you can choose the value of k as an odd number, so that the chances are very low that we do have a similar probability, or the class will be biased towards either 0 or 1. Okay, so this is something which you will observe. But now the question is, one question could be that how basically we can measure these distances. Another question could be that how we will be able to determine that for which particular data set what is the good value of k. Maybe it will be 3, maybe it will be 5, maybe it will be 7. We don't know, right? And how we will get to know, how we will be able to get an idea that okay, this is the efficient value of k which we can work upon. So both of these discussions we will do in this session, where the very first thing is you have to understand whenever we're talking about distance metric, as I told you, that let's say you will be having a new data point, right? And there are multiple distance points that we have, right? Multiple values that we have. And let's say some new data point came into picture. Now I want to examine that with respect to this data point that we have, there are multiple points, right? We need to check it out that, how far this new data point with respect to every point that we have, right? And then mainly we will try to find out that what is the top 3 minima distances that we have in this particular part. So in order to examine the distance of, let's say, this point to this point, this point to this point, this point to this point, right? I hope you must understand that we always have 2 points, right? One is P1, one is P2. So let's assume that we do have 2 points, P1 and P2. And the major purpose is, let's say this is a new data point that we are dealing with, and this is the original data points that is provided by the data set that we have. So this is the data set points that we have, right? Now, in order to check the distance between these 2 points, the very first metric which we have is Euclidean matrix. Now let's assume that the point P1 contains the coordinates as x1, y1, and point P2 contains the coordinates as x2, y2. So the first way could be the Euclidean distance way, right? We can examine a Euclidean distance, which basically helps us to understand the distance between the 2 points, which could be square root of x2, or you can say, yeah, one and the same thing, x2 minus x1 whole square. Let me just reopen it again. I think there is some issue happened. Let me again talk about the point. So what we are talking about is we have 2 points, right? P1 and P2. P1 and P2. So what I was talking about is, let's say P1 is having a coordinate x1 comma y1, P2 is having a coordinate x2 comma y2. So one way could be the Euclidean distance, where the formula to evaluate the Euclidean distance could be, as we have seen, Euclidean distance could be square root of the difference between x2 and x1 whole square plus the difference between y2 and y1 whole square. So this is one of the way. The second way could be where we will talk about something called as Manhattan distance, another distance metric. Now by default, I will show you in the documentation as well that it would be Euclidean. So there is some parameter called as P, which I think when it is equals to 1, it indicates Euclidean, and when it is equals to 2, it indicates Manhattan, or it might be vice versa. Let's refer the documentation for this, but because usually I don't prefer to cram these things. SK Learn, KNN documentation, and also I would suggest you all also, please don't cram anything. Everything is mentioned in the documentation and it keeps on changing. So it would be great if you can just refer the documentation for this per se. Now you can see when P is equals to 1, this is equivalent to Manhattan. So it clearly indicates that when the P equals to 2, which is by default, let me show you this part as well. When the P is equals to 2, it indicates the Euclidean distance. So here you can see default value of P is 2 only. That's what I was talking about. That default is a Euclidean distance. It means that when you are calling at any point of time KNN algorithm in your code implementation, in terms of getting the distance value, it will always prefer to go for Euclidean if you will not manually tap upon any P value as 1, right? When you're mentioning the value of P as 1, then it will be talking about a Manhattan distance whose formula is the difference, absolute difference between the value of x2 minus x1 plus absolute difference between the value of y2 minus y1, like this. So basically, if I'll ask you, if someone will ask you that, what is the difference? Okay, formula wise, it's clear that, okay, this is how basically we will be able to evaluate the Euclidean and Manhattan distance. But what is the internal intuition behind that? Where these two distance metrics are different? It's very simple to understand. For example, let's say I have this point A, and let's say this is point B. So A is the source, let's consider, and B is the destination, let's assume. Okay? And there can be several ways to go from the source to destination. Okay? Now, one way could be where you can say that I'll directly take this path, moving from A to B. Now, A is having coordinate x1, y1, B is having x2, y2. Now, this is something which I'm representing by green header, is the Euclidean distance way, right? In this particular thing, you are saying that I will be able to calculate the distance via the direct path. Why should I go for, first of all, A to that intermediate path and then this path to B? So Euclidean distance is direct path, which is basically able to give us the direct value. But another way could be where you can say that, what I will do is I'll directly, first of all, add this distance, then I'll add this distance, and that will also help me to reach to destination B. That is also a good way, which is a part of a Manhattan distance. But usually in terms of optimization per se, if you will be able to understand, Manhattan has lesser calculations as comparable to Euclidean, because we are doing a squaring and then we are applying a square root of the same. But it is quite optimal way to, get that distance value. Anyhow, you can use any one of them. As I shown you, both of them are already available in our documentation. It depends on the data set. It might be the case that for few data points, Manhattan is a good metric. For other data points, Euclidean is a good metric. So there comes another module which we will discuss in the upcoming part of the course, called as hyperparameter tuning. So whenever I'm talking about any parameter, for example, in the KNN algorithm, this value of P is a parameter, right? This value of K is also a parameter, right? So this is called as hyperparameters. Now, hyperparameters are those parameters which we will have to experimentally choose depending upon what kind of data we are using, right? So there are different algorithms that we have to tune our data set with respect to the hyperparameters that we have. For example, very famous algorithms are something called as grid search CV, right? Something called as random or randomized search CV. Okay, so we will talk about what is this CV. It is cross validation. We'll talk about in the upcoming module that first of all how basically with respect to every algorithm that we have, we can tune the hyperparameters with the help of these two algorithms, right? So as of now, you can consider that we will, in terms of our implementation per se, pick the default value, and with the help of which we will try to understand the concept end to end. But you should have that thing in your head कि we can in future sessions tune our hyperparameters also depending upon what kind of data we are dealing with the help of this hyperparameters algorithm, for example grid search CV or randomized search CV. So wait for that particular module to come, with the help of which you will be clearly able to understand. And by the way, this particular algorithms will be equally valuable and valid for all the algorithms that we have explored so far in machine learning, right? So you can apply these techniques of grid search CV and randomized search CV to check all the hyperparameters available in different algorithms that we have. It's not only for KNN, it's not only for linear regression, it's not only for logistic regression, it's not only for decision tree, it's equally valuable for all the machine learning algorithms wherever you want to tune your hyperparameters of the algorithms. So I hope it makes sense. So one metric we have seen as a distance metric is Euclidean. Another one I have talked about is Manhattan. Now the last one, now you will observe that these two metrics which we are talking about it does work well, but it does work well on the numeric data, right? On the numeric data points. So we will be having, let's say 2D, 3D, 4D data. So we will be having the value of X, we will be having the value of Y, we will be having a value of Z if it's a 3D data and so on. So if it's a numeric one, we will be easily able to map the data points that we have. But the question you can ask from me is, Priya, what if we will be dealing with any categorical data? Or what if we are dealing with any binary based data that we have, right? Binary like 100101110. So in that case, obviously we cannot map that data points, that kind of data values in our 2D graph, 3D graph, 4D graph and so on, because we don't have a numeric data in that place. So in that case, there comes another distance metric which we call as Hamming distance. So this distance metric will work well specifically for either categorical or binary data. I hope you all know what is the meaning of categorical and what is the meaning of binary data. For example, let's say you're working with a string and there are two strings that you have. One is A, B, C. Another one is, let's say, you can say D, B, C. In that case, if I'll ask you what is the distance between these two strings, Hamming distance says just pick up the values or the strings where there is not a match, right? For example, here you can see you will be having A and D. So there is a mismatch. So here it will become 1. There is a match, so it will become 0. There is a match, it will become 0. So now add all the values that you have. Now it will become the answer as 1. So you will be able to understand that wherever there is a mismatch, that is 1. Wherever there is a match, that is 0. Just add all the data points. That will give you the final distance value that we have. That will provide you a final distance value that we have. Okay. Similarly, same thing you can imagine for binary based data points also. For example, you are working with binary data 10, 01, 001. Okay. Now let's say you are dealing with another data in which you will be having 01, 01, let's say 010. Okay. Now, if I'll ask you how much is the distance between these two data points, obviously in this case you cannot apply Euclidean distance. In this case, you cannot apply even the Manhattan distance. The only way via which we can solve this problem is via Hamming distance only, where we will check it out. These two metrics, where is the difference? Where is the data points varying? So here you can see these two are different, so value is 1. These two are different, value is 1. These two are same, value is 0. These two are same, value is 0. These two are same, value is 0. These two are different, value is 1. These two are different, value is 1. So in this case, again, you can easily able to understand, just add all the ones that we have. So the distance value will become 4. So this is the distance value which we will be able to get here. So by saying that, always remember, if at any point of time you are dealing with categorical data in your data set, or you are dealing with the binary based data, you can always prefer to go for this Hamming distance. How basically it will be evaluated? You have to check each and every character that we have. Wherever the value of x is not equal to y, right? Consider that as 1 and just do add it out until the end of the string. So this is the way. Just do the addition wherever there is a mismatch, and whatever be the final value you will be able to achieve, that is something which you will say it as a Hamming distance. I hope it makes sense to everyone. So in this way, we will be having these 3 different type of distance metrics which I have to discuss today. Apart from this, now another second question of today's objective is how we will be able to determine this value of k. So as again we refer the documentation, you can see by default the value of k is 5. Means by default, if let's say we will not working upon the number of nearest neighbors, so it will always take the value as 5. Can you see n underscore neighbors is a parameter which is by default as 5. So by saying that, what I mean to say is that it's a hyperparameter again whose value is by default approximately equals to 5. Means always it will try to look for 5 nearest neighbors at any point of time. But let's say you want to check that for your data, what is the specific value of k? In that case, again, we will apply this techniques of grid search CV and randomized search CV, which we will discuss in the upcoming session. So their hyperparameter tuning is required. So we will discuss that part of hyperparameter tuning in a separate module altogether. There is a depth conversation which we will do in depth regarding these 2 points, right? So with this, I think we can end today's discussion. I hope it is pretty much clear to everyone. So what things we have discussed? Majorly the distance metric, 3 distance metrics we have discussed in detail, mathematically, Euclidean, Manhattan and Hamming. After that, we have discussed that the value of k is by default 5, but if let's say we want to change it, we can change it depending upon the algorithms that we have for hyperparameter tuning, which is either grid search CV and randomized search CV, which we will discuss in the upcoming module. So with this, let's end today's video. I'll see you all in the upcoming video. Bye-bye everyone and see ya.